is big like image right now.
The microphone. Yeah, you can go up to the stage. Up here. Yeah. Also, you can see. Put on my pocket. Yeah.
Yeah, and also yeah. Some of like yeah, it would have be very interesting. It's just like we have a different focus.
Do I need to open the video? Do I need to open the video and audio? In my computer.
You can turn them off if you want.
Okay.
Hi, good afternoon. Good afternoon. Good afternoon. Bonjour, 下午好. Good afternoon. Okay, 下午好. Bonjour, good afternoon. Okay. So our second session of the lightning talk will start soon. Okay. So and the talk is roughly 10 minutes per person, and I'm the host. So it will run around 1 hour. We have 6 speakers on the topic of social NLP and agents and AF work, this interesting topic. It's my honor to welcome Dr. Bobo Li, who is a research fellow with Professor Wang Li and Professor Winnie Su. He will be talking about. Great, let's welcome Bobo.
Okay, thank you. Okay, thank you. Hello, everyone. My name is Bobo Li, and today the title of my presentation is Taming Axial Observer Asymmetry in Agents via Dialectical Alignments. And this paper is published at ACL 2026. First is the background. In psychology, there's a concept called axial observer asymmetry. Let's look at a simple example in the daily life. When a person arrives later to the office, the boss may think that he is late because he is lazy. But for the person himself, he may say that, oh, I'm late because of the traffic jam. So that's the axial observer asymmetry. It means that the people tend to attribute the failure or the behavior to the environment, but they may tend to attribute the failure of other people to their personalities. So I think this is a very common symptom in your daily life. Then we can ask a question. Because the large language models are trained based on the human-generated corpus, so will this bias also exist in the large language models? When we use the AI agents, we ask them to complete some task for us, and we will assign a rule for better complete the task. For example, you are an expert in coding, you are expert in document writing, and if they have the specific roles, when there's a error happens, and they may have the different attribution for the same errors. For example, if there's a bug in the code, and the executor agent will say that, oh, maybe it's a server issue, but the review agent will say that, oh, it's a logical error. So even with the same failure, the different agents from different roles, they may have a different attribution. And in this paper, we do a preliminary study to verify this symptom exists in the current large language models. So we build a data set, and we extract the AI agents interaction traces, and we assign the different roles to the AI. For example, you are an agent, you are an agent B, and the interaction history was performed by you. And but another prompt is that you are the reviewer agent. So these are different roles, and we test the same background but different roles, and we compare whether they will show the different attribution for the same error. And the dataset contains 2,200 traces and across 10 domains. And the results are very significant. About 20% cases, they will show the AOA symptom or the actor-observer asymmetry bias. So after recognize this problem, we try to propose a framework to solve it. We find a task is about a QA task. Given a document and given a question, we ask the agent to conduct the task with two steps. First is the retrieval. The second is writing the code to solve it. Then we can distinguish the error from two aspects. If the evidence list is correct or comprehensive, and the final answer is not correct, so this is an internal error. That means the executor writes the wrong code. But if the evidence list is not correct, then we can say that because you didn't provide me with the full evidence, so I cannot write the correct code. So that is an external error. So after we distinguish the different errors, and we can generate the thinking process with the three steps. The first is the thesis, and the third one are antithesis and synthesis. The first step is to make the agent to think from his own perspective. The second one is ask him to think from the opposite perspective. And the final one is a comprehensive conclusion. And after we generate the thinking process, we can use the SFT and GRPO to optimize the model to give the stable answer, even they have different roles. This is the three-step thinking, and this is the reward. And this is the performance of a model compared to the current large language models. We can find that all models achieve the best performance and the lowest AOA bias. Also, we conduct the detailed analysis. If we only conduct two views on the dataset, but without any training, they will not perform very well. But after the training process, it improves the performance. And also across different evidence lengths, our model achieves the best performance. And this is a transfer learning study. Because our model is trained on the QA task, we want to demonstrate that it can also perform better on the AFB bench. This is a benchmark that we built in the preliminary study. The agents had never seen this dataset before, but it can also show a lower AOA bias. That means that our model learned a general inference strategy rather than a specific rule for the QA task. Here's the contribution. First, we identify this bias in LM systems, and then we build a dataset to verify it, and finally we propose a framework to reduce it. Here is the resources, paper code, data and project. Thank you.
Questions or Dr. Lee? Any questions? maybe Navin, do you want to ask a question? It's also welcome.
All right.
So maybe I can ask a quick question.
Okay.
Dr. Lee, you have many tasks in charge. So which one do you feel the most challenging? Coding, we have tasks. So which one faces the most significant challenge, and which one has the largest delta improve from the framework? I'm curious about this aspect.
Oh, thank you. That's a good question. But we didn't conduct the detailed analysis about the performance. We just have a overall performance. Okay, maybe we will conduct it later.
Okay, great. Amazing. Thank you so much.
Thank you. Thank you.